Okay, so this video is going to talk about the Pythagorean theorem, which is the thing that we got to understand if we are going to be able to use the distance formula. The distance formula is going to allow us to find the distance between 2 points on the coordinate plane. Okay, so let's say, for example, okay, right now you don't see these dotted lines here. So let's say we have this line that starts at 0.21, which is 2 on the x, 1 on the y, and it goes to 0.95, which is 9 on the x, 5 on the y. Okay, the way that we would find that distance, we want to know how long is this line? How many units is this line? Okay, so what we would do is we would create a right triangle. So think about when we did rise over run. We're basically doing the same thing. Okay, so when we found the rise over run, we just made that into a fraction, so we knew the slope of the line. Well, now we're going to use that same information to find the distance of that line. So the Pythagorean theorem goes like this. So we have a squared plus b squared equals c squared. Okay, what does that mean? Okay, Pythagoras, actually some people think it might have been one of his buddies, but he gets all the credit for it. He realized that for any right triangle, that's a triangle with a 90-degree angle right there, is a right triangle. He figured out that the length of this line, called the hypotenuse, is the square of the other two sides squared. So a lot of fancy language. Okay, so we're just going to call this long side, side A. We're going to call the shorter side, side B. And then this hypotenuse is this kind of diagonal line that goes from these 2 points. So we'll call point A and point B. And it doesn't really matter which one is A and which one is B. Technically, we want the long side to be A and the shorter side to be B, but in the formula, it doesn't make any difference as long as you get side C where it belongs. Okay, so what we want to do is find the distance, like from this point here to this point here. So we'll draw a little point in here. Okay, and then we want to count that distance. So it's 1, 2, 3, 4, 5, 6, 7. Well, we look here, the coordinates would kind of tell us that. Okay, so this is our x coordinates, right? X coordinate. And it's 7 units away. Okay, so we know that A is 7. Okay, and B is this vertical distance between the 2 points. All right, so let's use another color to signify that. We know that that's point Y and that's Y coordinate. Okay, so this distance up is 1, 2, 3, 4. So B equals 4 units. Okay, so it's 7 across, 4 up. And if we were finding the slope, it would be rise over run would be 4 over 7. Well, we're not doing that. We're going to use A and B to plug into our formula here. And we're going to figure out this distance C. Okay, so let's plug in our numbers here. A squared, so we've got 7 squared plus B squared, which is 4 squared, equals C squared. Okay, so we're going to simplify this, and then we're going to solve for C, and that's going to tell us this distance. Okay, so 7 squared, we can use your calculator on this if you need to. Okay, I happen to know that 7 squared is 49, plus 4 squared is 16, equals C squared. Okay, 49 plus 16 is 65, equals C squared. Well, I don't want to know C squared. I want to know C, so let's think back to our solving radical equations. We squared everything. Well, this is going to be the opposite of that. When we solve with an exponent, we're going to do the opposite of that. So we're going to take the square root of both sides. Okay, well, the square root of a square just leaves us the C. It's just the opposite of what we did with the radical equations. Anytime we have a square and a square root, they cancel each other out. We're just left with the thing inside, equals root 65. We could try to simplify this. It's 11, let's see, 12 times 5, 13 times 5, so they're 2 primes. So it would just be root 65. But if we want to actually get a number for this, we would punch this into our calculator. see, second function, square root. I don't know if you can see that. You probably can't. I'll put it on here so you can see it. Second function, square root, 65. Enter equals 8.06 something, something, something. So it depends on what we want. We'll just say it's 8.06. Okay, so that's how we do the Pythagorean theorem. In the next video, we're going to take this idea from the Pythagorean theorem. We're going to learn a formula where we can just take the coordinates, punch them into the formula, and it will spit out this distance for us.